The following question asks us, would you expect sodium or magnesium to have the greater first ionization energy, and which should have the greater second ionization energy? So in order to approach this problem, the first thing that I did was write each of the electron configurations for the neutral atom. We know ionization energy is the energy associated to removing an electron from an atom in the gas state. So if we're removing one, so the first ionization energy, for that of sodium, we'll end up getting a cation, and remember cations are positively charged ions, and it'll become isoelectronic to that of neon. If we remove one electron for that of magnesium, it will end up having an electron configuration of neon 3s1. I'm sorry, go ahead and write magnesium plus. So in this case, sodium, when we lose one electron, becomes isoelectronic to that of a noble gas, which is a stable configuration. However, in the case of magnesium, magnesium ends up becoming a half-filled s orbital. This is not going to be favorable because this is less stable than that of a completely filled orbital. So in the case of the first ionization energy, magnesium is going to have a greater energy than that of sodium because it's going to require more energy to remove that one electron from the 3s2 orbital, where it's a stable configuration to that of a half-filled orbital. Now in the case for the second ionization energy, what's going to happen is we're going to be removing 2 electrons in this case. So if we remove 2 electrons from that of sodium, it's going to have an electron configuration to that of fluorine, where at this point, if we remove 2 electrons, we're now removing an electron from its core electrons, which requires a significant amount of energy. In the case of magnesium, if we remove 2 electrons, it will become isoelectronic to that of neon, which is a stable configuration. So in this case, for the second ionization energy, sodium is going to have a larger a greater second ionization energy to that of magnesium. And this is because you're removing an electron from its core electrons, which requires a significant amount of energy to do so.